Okay. So we're going to now explore what happens when you're given two sides and one angle. So yesterday we were looking at two angles, one side. Today we're going to look at two sides, one angle. All right, case one. Given that angle A is obtuse, do you guys know what obtuse angle means? Over 90. Over 90 degrees. Over 180 is not in a triangle. Side AB has a length of 10, as shown below. Point C must be somewhere on that dashed line. Okay, you and your partner have to answer the following questions. If BC is 11, how many triangles can you make? If BC is 10, how many different triangles can you make? And then if BC is 9, how many different triangles can you make? So talk to your partner. C has to be on the dashed line. Okay, so C has to be somewhere here, okay? So C has different lengths. BC has 11, 10, or 9. How many triangles can you make if you change those lengths? If BC is 11, how many triangles can you make? If this is 11, how many triangles can you make? Can you make a triangle if that is 11? Yes.
Why wouldn't you use it?
Why? Okay. Okay, you can make one triangle. Basically, it has to be right there. Okay. If BC is 10, how many triangles can you make?
BC?
Yes.
Oh, then it has to be.
No, you can't make a triangle.
What?
BC is 10, that's the same length. How can you make a triangle?
Oh, like it won't reach the.
It has to reach this side.
I'm so stupid.
Okay.
Then BC, if it's
Okay, you cannot make a triangle. It's too short. Or actually, it's impossible. Any of these lengths has to be longer than 10, right?
yes, the last one.
Any of these has to be longer than that AB. Okay, so then if BC is 9, how many triangles? Nothing. It's too short to even reach that other side.
I think we got it.
Okay? All right. Case number 2. Angle A is acute. What does acute mean? Less than 90. Side AB still has a length 10, shown below. C has to be somewhere on the dashed line, and that H is a altitude, so that means it makes a 90 degrees with the base, and that length is 5. Okay, with your partner, same question.
Okay.
How many different triangles can you make? All right, if BC is H, how many triangles can you make? 1. All right, if you put 0, please talk to somebody. Let's figure that one out right now. If it's H, you just have a right triangle, okay? If BC is less than H, how many triangles can you make? 0. You can't even reach that line. If BC is 6, how many triangles can you make? 2. If it's 6, where is 6? So the altitude is 5, right? This side is 10. 6 is somewhere between 5 and 10. So it could be here or here. So it could be here or here. Does that make sense? 6 is between 5 and 10. So that length is between 5 and 10. So it has to be somewhere in between here, or it could be here as well. Okay? All right, last one. If BC is 11, how many triangles can you make? 1. And it has to be here, right? Between 5 and 10, that part is only numbers between 5 and 10. Bigger than 10, it has to shift to the other side. Okay, so what we're going to do today is we're going to explore this problem when there are two triangles. How do you know when there are two triangles? And if you do know there are two triangles, can you solve for both triangles? So this is the ambiguous case of law of sines, when what happens is your measurements actually don't give you enough information. The measurements they give you could possibly create two triangles. Okay, and this is the case of SSA, so two sides, one angle. All right. This is a very nice summary. So if you go home and you do your homework and you're like, I don't know how many triangles are possible, you look at this chart. Basically, it depends on your altitude. Okay, so let's go ahead and try this first one. Solve triangle ABC given that A is 7, B is 6, and angle A is 26.3. So A, B, C. Side A is 7, side B is 6, angle is A is 26.3. Okay, so this is the case of two sides, one angle. Two sides, one angle has the possibility of being an ambiguous case. We need to figure out, is it possible to only have one triangle or is it two triangles? Okay. This always is very hard every year when I try to teach it. So I'm gonna try. Okay, the measurements are given, right? The parts that are given are the only parts that cannot change. Okay? So 6 is given, 7 is given, and then 26.3. I can't change any of those. Besides those, I can change it. I don't, the triangle might not exactly be the way I drew it. So, looking at this angle is fixed. This side has to be fixed because of the angle, kind of keep it fixed, right? 7 is the problem. This side does not have to be the way I drew it. It could swing all the way to here. So, the question is it possible for me to draw this, where this angle is obtuse instead of acute? That's the question. If it is, then I have two triangles I have to solve. If it's not possible, then I can just solve it as is. So, is it possible to draw it like this? We don't know.
Yeah.
So, what's the deciding factor? The deciding factor is the altitude. Is it a number, so is 7 a number between the altitude and 6, or is 7 bigger? So looking at your previous case, right? So remember I said on the previous question you had 10 was here, and then you had altitude was 5, and you had that third side was 6, which ends up being in between. That's one side 10 and that one side 5. When that number is in between, you have the chance of swinging to the left or right. But when that number is bigger than that side, then it's only possible to create one triangle. So, okay, long story short. The question is 7 in between these two numbers? No. The way I wrote it, it's already not making sense. Is 7 ever going to be less than 6? No. So then it has to be this way. You guys are stuck. Okay. Take a look at your triangle like this. This side is 7, right? It is not possible to be... to create an isosceles, this has to be 6. Okay. 7, okay. Isosceles triangle means that this side is 6 and 6. Is it possible for 7 to be in here? No, of course not. This is really long. It has to be on this side. So this is the only way to draw this triangle. Okay.
I understand.
You understand? Okay, so it's just kind of like deduction reasoning. If not this, then not this, not this. You only have one possible answer. Okay, so this is impossible. So therefore, all we need to do is just solve it with law of sines. Sine 26.3 degrees over 7 is equal to sine b over 6. So basically, it says solve the triangle, so basically we gotta figure everything out. So same thing as your homework last night. All right, so go ahead and figure out all the missing items. And the whole reason we're doing this ambiguous case and we have to figure out whether it's ambiguous or not is if you don't do that, your calculator will only give you one triangle. If you use law of sines, you can only find an acute triangle. You can never find the obtuse triangle. So you have to draw it out yourself in order to figure this out. Anyways, go ahead and figure out the angles and the sides that are missing. Since we figure out there's only one possible triangle, using the calculator will solve everything. All right, let's give you the answers. So angle B is 22.3 degrees, C is 131.4 degrees, and then side C is 11.9. Just a reminder, make sure you do put degree sign. All right, so we'll kind of summarize. When you have a case of side angle, two sides, one angle, you have to check. How do you check? This might be a faster way. There's always one angle and a side that's stuck to it. The side that's not stuck to it is the side that you need to check. Okay, the angle and side that's fixed, that's the side, that's the thing that you can't move. The side, the last side, is the side you're gonna move. Okay? All right, let's try another one. Solve this triangle given these things. All right, so let's go ahead and draw it. A, B, C. Side A is 6, side B, Side A is 6, side B is 7, angle A is 30 degrees. Okay, again, what we want to do is figure out the angle and the side that can't change. That is this angle and this side. The side that's immediately attached to the angle. That means 6 has the potential to move. Okay, so first you check. Is 6 longer than 7? No. If it's longer than 7, you only have one triangle, just like the previous one. Right? This side is longer than this side, you only have one triangle. It's not. Ooh, that's a scary case. Then we need to check the altitude. See if it's going to be in between the altitude, or is it exactly the altitude? Is it shorter than the altitude? But the altitude is going to be the deciding factor. So the question is, how do I find the altitude, or how do I find h? How do I find h? I'm going to have to utilize this right triangle. We have one angle, and that's 30. I don't know this side. I know 7. And that forms a right triangle. So this angle with these two sides makes what trig function? Huh? Iris? Sine. Only looking at the red triangle, because the red part is the right triangle. Are you guys with me?
Yeah.
Thank you. So sine of 30 degrees is equal to opposite over hypotenuse. Okay, so h is equal to 7 sine 30. Yes?
Could you do the 30-60 triangle?
30, yeah, you can, yes. So sine 30 is actually what value? Oh, yes, the whole thing is 3.5. Sine 30 is 1/2, right? So then this is 3.5. All right, this is 3.5. So now the question, is 6 shorter than 3.5, equal to 3.5, or in between 3.5 and 7? In between. What does that mean? Two triangles. Okay, when we have two triangles, we got to draw both. That means one triangle is the way I drew it. The other triangle is going to be here where 6 is here and this is obtuse. The diagram is crazy, I'm sorry. We have potentially two triangles. One is this one. This is an acute angle. And then the other one is like this, and this is obtuse. All right, we have two triangles. So let's go ahead and write all the measurements that we know. So we know this is 7, this is 6, this is 7, this is 6. This is 30 degrees on both of them. If you use your calculator right now and you perform law of sines, you will only be able to get this triangle. Law of sines has limitation because your calculator only gives you angles between 0 and 90 when you use the inverse sine function. So how are you going to find this? Let's find out later. But for now, please solve this triangle. And then I'll tell you, once you solve this, I'll tell you how to solve the other one. Okay. Angle A, angle B, angle C, A, B, C. Okay, so B is 35.7 degrees, C is 114.3, and C is 10.9. All right, now we need to solve for that second triangle. Remember, the second triangle exists within the first triangle. It's just that it's shifted over, right? Okay, this is going to be a little bit hard. This is A, this is B, this is C. So B we found out is 35.7. That's the acute triangle that we drew. Now we need to find one where B is actually the obtuse angle. Okay, this is a little tricky. This triangle that's existing within the old triangle, this part is 6, right? Yes? Therefore, this creates an isosceles triangle. 6 and 6. Are you guys? 6 and 6. That's an isosceles triangle, right? And what we know about isosceles triangle is that if the two sides are the same, what does that mean about the opposite angles? They're the same. Therefore, this angle is also 35.7. Can you guys see that? When you flip that side into the inner part of the triangle, you create an isosceles triangle. When you create an isosceles triangle, you can assume the two opposite angles are exactly the same. Therefore, this obtuse angle we're trying to find is going to be the supplementary angle. So 180 minus 35.7. Are you guys with me? Okay, so this angle is 144.3. Okay, so this is this triangle that I'm trying to draw on the right, 144.3. And then you're going to use that angle to do a law of sines again to find all the other measurements. Because you can see that C is going to be shorter now that you drew it the second way. So you have to do law of sines again, but with B being 144.3 degrees. So that's given angle A is 30, side A is 6, side B is 7. So the parts that we found in the new triangle is that angle B is 144.3. Angle C is very easy to get, just triangle sum. So that is 5.7. And side C is 1.2, about 1.2. Okay, so the tricky thing on this question is, do I have two triangles? Okay, once you figure out that there are two triangles, you're gonna draw one with just acute sides, and then the other one is you have to draw the obtuse, but that exists inside the original triangle. Remember that that creates an isosceles triangle. So once you use your calculator to solve for the original triangle, isosceles creates the same angle on the other side. Find the supplementary angle, which is the new angle B, and then solve everything else. Okay, let's try another one. Determine the value of B that will produce the number of triangles. If A is 10, B is 42. Okay, let's draw this diagram. A, B, C. Find the value of B. Okay, if A is 10, B is 42. They want to know side B. That's this side. Okay, remember we were saying there is, so this is the case of side-side angle. Okay, side-side angle means there is a chance there could be an ambiguous case. So fixed angle, fixed side. The red one is the only side that's gonna move. The question is, what does that have to be so you have two triangles? What does that have to be if you have one triangle? What does that have to be if you want no triangle? Okay, you're gonna do it with your partner, but I'm gonna give you the hint. The hint is it depends on the altitude. So you're gonna have to find the altitude. The altitude is the deciding factor to whether you have one triangle, no triangle, or could you have two triangles. Okay, go ahead and do this. Let me know when you're done. Let's start with no triangle. So first, figure out this number, that's 6.69. No triangle has to be shorter than the altitude. You just can't even reach the other side. One triangle, that's if you're exactly the altitude, or it could be longer than that other side. So you basically have a bigger than the isosceles triangle. If it's two triangle, then that B value has to be between 6.69 and 10. I'm sorry, this is also equal to. It could be an isosceles.